We are now in section 7.4 talking about partial fraction decomposition. This is example number 1 of 3 for this lesson. This one is going to be dealing with decomposing a fraction with distinct linear factors, meaning something like this that you see down here. They're different from each other and they're linear, so notice that they're each in the form, they could be represented by mx plus b. And so these are considered linear. They don't have any exponents, anything like that. If this is the case, then we are going to follow a couple of steps in order to split these fractions up. And we'll go into the example that'll give you a little bit more detail with that. But in general, we're going to split the denominator up. Well, we've got the x and the x plus 3. We're going to give each one of those their own fraction. It really doesn't matter the order that these go in, so the fact that I have them flipped around doesn't make any difference. And then there's going to be a single unknown constant as the numerator. We don't need to worry about the numerator on this side. We're just going to let that play out as the problem goes along. But then we are going to, in the examples, try to figure out what are a and b so that we can have a split of two simpler fractions for this one more complicated fraction. This is just a general example to start us out. And what we'll do here is take a look at one in particular on this next page. Here is the main example that I would like to look at for this first case. We have a fraction with, this is supposed to be distinct linear factors, but you'll notice that this is quadratic in the denominator. So what we actually have to do first is we're going to need to factor this. That's really the first step on all these problems, is you want to be able to factor that denominator first. So I have that factored as 2x minus 3 and x plus 1. Maybe pause the video if you need to go back and check to see how that factoring works. But we've got that factoring, and now we're going to split this up into two fractions. One fraction for each of these denominators. Remember, we are going to ignore the 4x minus 11 for right now. So here's what we're going to do. We're going to start with one fraction. We use the 2x minus 3. Could use the x plus 1. It really doesn't matter the order. We'll do a single unknown constant divided by that denominator. Then we're also going to have a fraction for the x plus 1. And so we get a fraction for each distinct linear factor, the denominator, that we have. From here, we're going to go on and solve this in kind of a specific way. You'll want to make sure that you do it in the same way as I'm doing it right now, but we want to make this an equation without the fractions. None of us likes fractions. Let's get rid of them. The way to get rid of the fractions, if we just treat this as an equation, is we can multiply everything by the least common denominator. So in that case, this is going to be just both of those pieces that we have here, the 2x minus 3 and the x plus 1. In doing this, it's going to eliminate certain things on each side of the equation. Over here, it's going to get rid of the entire denominator. Over on the right-hand side, it's going to get rid of one of the denominators on each one. So let's start over on the left-hand side. We get rid of the entire denominator. What we'll have is just 4x minus 11. On the right-hand side, we will be eliminating the 2x minus 3. The x plus 1 is going to be left over on top, so we're going to be left with a times x plus 1. Then we go to the b fraction, and that one is going to be left with b times 2x minus 3 because the x plus 1's cancel out. And so now we've got a version of the equation that doesn't have any fractions. Next thing is to simplify and try to get our right-hand side to look like the same form as the left-hand side. Now I want you to notice this left-hand side has an x piece and it has a constant piece. And so we're going to try to match that up over here once we have everything sort of distributed out. So I'm going to distribute the a and the b throughout these and just kind of have it all laid out for now. We'll have ax and then plus 1a. And over here we're going to have plus 2bx. You don't have to write it in that order, but you can. Or you can switch it around a little bit. And then minus 3b. Now, once I have this, what I want to do is combine the like terms together. We always do that in an equation. The like terms are going to be the ones that have x's, and then also the ones that don't have x's. So I'm just going to group those together, making this ax plus 2bx. That's one group. And then I'm also going to group together the a minus the 3b, because these are like terms. Alright, once I've got that, now I want to isolate things a little bit more at just one other step that you may or may not think about otherwise, but I'm going to factor that x out of those so that I have just the a's and b's on the inside of this. So I'm going to have a plus 2b, and I'm going to bring the x to the outside. Over here I've still got the same thing, a minus 3b. Alright, so once I get to this point, I want you to notice here that we have an x piece and a constant piece on the left side. We have an x piece and a constant piece on the right hand side. And so what we're going to do is actually make those parts equal to each other. I'm going to grab another piece of paper here just so we have some room. Here's my same equation. We've got x term going with x term. Now I'm going to make an equation out of that for my system, but I'm going to leave the x's out of that. The x is just a variable. We just want to know what the a's and b's are. So I'm going to make an equation starting with a plus 2b equals 4. That's just the x parts taking out the x's. The other part is the constant piece, and that is a minus 3b is equal to negative 11. Those are the constant pieces to this problem. So now that we have that, we have a system of equations. We can solve this in really about any way that we so choose, but it just happens that normal elimination actually works pretty well here. It's a simpler system than what we were working with in the last section. So I'm going to just eliminate these a's. I'm going to do that by multiplying this first equation by negative 1 and then adding these things together. So then I'll have negative a minus 2b equals negative 4. Add those together, and the a's cancel out. I get negative 5b equals negative 15. So knowing that, I can say that b is going to be equal to 3. So there's one of my important pieces here. I need to also find the a, so we can just plug it back in and find what a is. I don't think I need to show those details to you. It's just plug in b, either one of those equations, a turns out to be negative 2. Now once we have the a and the b here, we want to go back and figure out what was it that we were trying to decide. We were really trying to figure out from this last page, we wanted to know how to split this fraction up. We just had a and b as unknowns. So now what we'll do is sort of just write the summary statement here, and that is, since we found a to be negative 2 and b to be 3, we can just take now and rewrite this equation, rewrite this formula. I'm going to use a different color. We can rewrite this as, well, it was a over 2x minus 3. A that we found was negative 2, so it'll be negative 2 over 2x minus 3. And then plus b over x plus 1. And our b here was 3, and so that's our second fraction. So this now is what we were trying to accomplish. We split up this more complicated fraction into two less complicated fractions using this partial fraction decomposition.